चैंपियन रहा है। ये बहुत ही बड़ा टूर्नामेंट है, तो अपना बेस्ट देना। ओके, पिक योर टीम। यस सर। सर, हमारी ऑर्डर।
Hello all. Welcome to the third week interaction session of the course Wastewater Treatment and Recycling. Let us wait a few more minutes so that others can also join.
Good evening, ma'am.
Yes, good evening. I guess we can start now. So let me share my screen. So before that, let me introduce myself. I am Sethulekshmi, third year PhD student at Environmental Science and Engineering Department of IIT Bombay. I am a Prime Minister's Research Fellow. So as a part of my teaching assistantship duty of Prime Minister's Research Fellowship, I am hosting this interaction session with you all. So before starting the session, let me hope that all of you have watched the three week 3 lecture videos of NBTL course, Wastewater Treatment and Recycling. So I hope let us start now. We have around 12 participants now. So let us start. I'll share my screen now. Before that, if there is anything you want to ask, you can ask now. Any query regarding the course, you can share it here with me now. Any suggestions are also welcome. I hope all the 12 participants we have now have attended the other two interaction sessions also. So if you have any suggestions to improve or anything to include, then that also you can share it here. So let us start the session. I'll share the screen. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Yes, thank you. So let us start. So before that, let me hope that all of you have watched week 3 session of week 3 lecture videos of NBTL course, Wastewater Treatment and Recycling. So on a brief note, in week 3, can anyone tell me what you have learned in week 3? Like what are the topics which are covered in week 3? All right. In week 3, the lecture included wastewater characterization. That is, what are the quality control aspects, or what are the properties which we have to look in wastewater to see the amount of pollution present in wastewater. You have learned about different parameters like different pollution indicators like color, odor, turbidity, then dissolved oxygen, then nutrient content, turbidity, and chlorides, hardness, then conductivity. So all these parameters were discussed in detail in the week 3 lecture videos, and also what about these parameters, their properties, their significance, their measurement methods, etc. were also discussed in the session. So based on the week 3 lecture videos, some questions are formulated which are based on the previous year assignment and exam questions. So those questions will be discussed in this session. So let us move on to the questions directly. So before that, I guess some people are again still trying to join the session. So let us include them also. So about first question, The preferable range of pH for conductive the aquatic life in conducive aquatic life in natural surface water bodies is option A 8 to 11, option B 6.5 to 8.5, option C 4 to 10, option D 2 to 6. So any answer, anyone?
Option B 6.5 to 8.5, madam.
Yes, that is the correct answer. I hope you have gone through the lecture videos. In the lecture videos, it is mentioned the significance of pH in any natural surface water bodies. So it is said that if the pH range in any natural stream, if it is between 6.5 to 8.5, it is well adapted for aquatic life. And as the pH drops or as the pH increases from this range, it causes disturbances to the normal well-being or normal life of aquatic organisms, including the microorganisms present in the system. So 6.5 to 8, maintaining this pH as environmental engineers or as environmentalists, maintaining the pH, this pH range is very important in any natural water body. So this is the correct answer. I hope it is clear. So let us move on to the next question. So next is a match the following type of questions. So on the left side you have different water quality parameters, and on the right side you have different methods for the determination of these parameters. So here you have parameters, and on the right side methods. So you have to match. So first is on the left side hardness, dissolved oxygen and metals. On the right side Winkler's method, atomic absorption spectrometry and nephelometry. So any answer, anyone?
Option C, madam.
Option C. Okay. Any other lead?
Ma'am, option A.
Option A. Okay. And any other answer, anyone?
Ma'am, or option D. Option A or option D. I am guessing.
Option B or D?
Hardness spectrometry, the dissolved oxygen Winkler method, metals atomic absorption spectrometry.
Okay. Let us see the answer. The answer is option C. Very good. Option C is one is against hardness is against nephelometry. So hardness, which is wrong actually. Sorry, it is a mistake. I will rectify it when I upload the mistake. Can anyone tell me what should be here instead of hardness? If this is a typo error. Nephelometry is a method used to measure what water quality parameter. So that is the next question.
Turbidity.
Turbidity. Yes, true. Turbidity is the right answer. I will change it and I will upload the PDF. So for now, very sorry for this mistake. It's a typo error. So turbidity goes against nephelometry. Nephelometric it is used for nephelometric method is used to measure turbidity. Then we have dissolved oxygen. Dissolved oxygen is matched against Winkler's method. Sorry. Yes, dissolved oxygen is matched against Winkler's method. Now we are using modified Winkler's method. Winkler's method is modified based on our convenience. And the modified Winkler's method is used nowadays for laboratory purposes to measure dissolved oxygen. So I hope you have learned about Winkler's method procedure in the lecture video. If not, please go through Standard Methods textbook by American Waterworks Association. So in this book, all the methods to measure all water quality parameters are clearly described. We in laboratory we follow this standard methods always to develop or to to understand the procedure for determination of different water quality parameters. So dissolved oxygen is matched against Winkler's method. Then the third one is metals. The metals, the presence of metals in water and wastewater is considered as an important pollution criteria, because many major heavy metals like mercury, then other cadmium, chromium, and all these are found to cause various health hazards in living organisms, including human beings. So various episodes of this water pollution associated with metals are reported all over the world. I hope all of you have heard about this famous arsenic pollution all over in the northeastern, especially in the northeastern part of India. So the metal pollution is one of the important thing which has to be looked at in terms of water quality. And here, as we are discussing the methods, the presence of metal ions in water is measured with the help of atomic absorption spectrometry. So metals is matched against 3 against B, 3 and B, 2 with A, and 1 with C. 1 is turbidity against nephelometry. So C is the correct option. So any doubt? Anyone? If there is any doubt, you are free to ask.
You can continue.
Yes, thank you. So let us move on to the next question. So based on these methods, I must tell you that again that we always follow this textbook, Standard Methods by American Water Works Association. So if you want to learn about any method, about measurement of any water quality parameter, you can refer to this Standard Methods textbook. So let us move on to the next question. The next question is the equivalence to the amount of oxygen required for total biochemical degradation of organic matter by aerobic microbes is known as A. Carbonaceous BOD, B. Nitrogenous BOD, C. Ultimate BOD, D. COD. So which is the right answer?
Is it carbonaceous?
Carbonaceous. Any other option? Anyone?
C.
COD, madam.
C. Okay. Any other answer?
COD, madam. Option D.
Option D. Okay. Let us see the answer. Option C, ultimate BOD, is the correct answer, because in this question it is said that the equivalence to the amount of oxygen required for the total biochemical degradation of organic matter by aerobic microbes is known as. Hence, our answer is ultimate BOD. So COD, someone has said COD, but our answer is not COD, because in COD is the chemical oxygen demand. In COD, we use a strong oxidizing agent in order to degrade all the organic matter present in a water sample. But here it is asked with the help of aerobic microbes, like what is the term given to the equivalence to the amount of oxygen required. So that is ultimate BOD. You might have learned about this curve in which this oxygen demand and time. So the curve is something like this. Here this is about 7th day. After 7th day, all the carbonaceous matter will get oxidized with the help of oxygen, dissolved oxygen present in water. So that is known as CBOD, carbonaceous BOD. After that, after 7th day, the nitrogenous organisms become active, and all some of the oxygen present in the water is getting used for the oxidation of nitrogenous matter, that is ammonia, which is in the reduced state, can reach to its uh, oxidized form, nitrates and nitrates. So for the oxidation of nitrogenous organic matter present in the wastewater sample, some amount of oxygen will be used. So that is known as nitrogenous BOD or NBOD. So in total we call it as ultimate BOD. So here it is asked the equivalence to the amount of oxygen required for the total biochemical degradation. So the answer is C, ultimate BOD. It is not COD because here we have used the term aerobic microbes. In the case of COD, we use strong chemical oxidant like potassium dichromate. So I hope it's clear. If there is any question, you can ask.
If it is asked to know the amount of oxygen required for only organic matter, then it is a carbonaceous BOD. Am I right?
Only the organic matter, carbonaceous organic matter, then it is carbonaceous BOD. Here it is said total biochemical degradation of total organic matter. So it is ultimate
So
BOD. Yes.
it contains organic as well as inorganic organic matter.
No. Here we are talking, when we say about oxygen demand, we are talking only about the organic matter. The inorganic matter is not degraded with the help of microbes. We are talking in this context only about the organic matter, but we are talking about the total organic matter. It is not said in the question, it is not mentioned whether it is of nitrogenous origin or carbonaceous origin. So it is ultimate BOD. See, if there is any nitrogen content, nitrogenous matter like ammonia present in the sample, it is also an organic matter. So it is also organic in nature. It is not inorganic. So when it is getting oxidized, it is nitrogenous BOD.
Okay.
Any other question?
Okay, madam. No.
In the case of COD, we usually talk about the organic compounds which are very difficult to get degraded with microbes, such as recalcitrant. Have you heard about the term recalcitrant organic matter? Recalcitrant organic
No.
matter or organic matter which is not readily biodegradable, but with the if we like, such as pharmaceuticals and all, so they are not originally readily biodegradable. If there is some pharmaceutically active compounds like pharmaceutical compounds, something like this, of this sort, if it is degraded with the help of an oxidant to a simpler form, then uh, from here now it has become like readily biodegradable. From here microbes can degrade them. So in the case of COD, such compounds which are recalcitrant in nature but they are organic in nature, they are also included. That is the difference between COD and BOD. But nowhere we are talking about inorganic. Here in this context, we are talking only about the oxidation of organic matter.
Okay.
So, any other question, anyone? So, if not, let us move on to the next question. Which of the following cause-effect pairs is incorrect? So, which of the following cause-effect pairs is incorrect? A. Suspended and colloidal particles, turbidity. B. Bicarbonates of calcium and magnesium, temporary hardness. C. Dissolved dyes and humic compounds, apparent color. D. Organic matters, BOD and COD.
A. Suspended and colloidal particles. Turbidity.
Okay. Any other lead? Anyone?
Option D, madam. Organic matters, BOD and COD.
Okay. Then any other lead? Anyone? So the question is, which of the following cause effect pairs is incorrect?
Ma'am, what is mean by COD?
COD, yeah. COD is the chemical oxygen demand. That means that, like, suppose you have wastewater, some amount of wastewater you have, and you have some compounds, some pollutant, some organic compound in it. Some organic compound like I know what I think you know what do you mean by organic compound, right?
Yes, ma'am. Yes, ma'am.
Yeah.
I understand.
Some amount of organic compound is there. So COD is the, like, for organic compound, like it when it gets degraded, it forms CO2 plus water. So for this for this degradation or oxidation, this organic compound will be in the reduced state. So when it gets oxidized to simpler compounds like CO2 and water, it requires some amount of oxygen. So it consumes this reduced compound, organic compound in wastewater, consumes some oxygen to get degraded to CO2 and water. COD means, like, whatever organic compound is there in your wastewater, like let it be any recalcitrant compound also which is not readily biodegradable, like those compounds also, when, like, how much amount of oxygen is needed is consumed by all the organic matter present in your wastewater to get decomposed to CO2 and water. So that is COD. BOD means, like, only the biodegradable organic compounds are converted to, like, how much amount of oxygen is needed to like for the degradation or oxidation of biodegradable organic compounds with the help of microbes. That is BOD. COD means all the organic compound is included. Whatever organic compound is there, like not necessarily that they are readily biodegradable, but with the help of strong oxidizing agent, how much amount of oxygen will be consumed. That amount of oxygen is known as COD, chemical oxygen demand. Is it clear? Is it clear for you?
Yes.
Okay. So let us come back. If it is clear, then let us come back to the question. So let us see the answer. The question is, which of the following cause effect pairs is incorrect? So let us see the answer. Option C is the incorrect statement, which is the correct answer for this question, because I'll explain. Suspended and colloidal particle, it is given that it is smashed against turbidity, which is a correct statement, because suspended and colloidal particles in water cause turbidity. So that is a correct statement. So A is not an answer for this question. Then option B is bicarbonates of calcium and magnesium, temporary hardness, which is also a true statement, because temporary hardness is, there are two types of hardness: temporary hardness and permanent hardness. Temporary hardness is caused by the bicarbonates of mainly calcium and magnesium. When they are present, like calcium bicarbonate or magnesium bicarbonate, when they are present in the water, they cause temporary hardness. But permanent hardness is caused by like compounds like salts like chlorides, sulfates, etc. of calcium and magnesium. They cause permanent hardness. So option B is a correct statement. So hence not an answer for this question. Then option C, dissolved dyes and humic compounds. The dissolved dyes and humic compounds, it is said that like they cause true color. True color means the color which is true to the solution. Like, but suspended solids are suspected to cause apparent color. Apparent, as the word suggests, apparent color means that can be removed easily with sedimentation or something. But true color is caused by the dissolved and suspended, like dissolved and colloidal impurities like dyes and humic compounds. So option C is incorrect. This has to be matched against not apparent, true. So option C is the answer for this question. Again, option D is organic matters, BOD and COD. Organic BOD and COD, when we consider, we talk about the degradation of organic matters, the amount of oxygen needed for degrading organic matter present in wastewater. So this match is correct, hence not a correct option for this question, because the question is which of the cause effect pairs is incorrect. So this is all about this question. Any doubt, anyone?
Madam, what is humic compound?
Humic compounds means like the like degradable colloidal type of compounds, like
Okay.
the humus present in the soil and all such type of compounds.
Okay. Okay.
Yeah. So if there is no other doubt, let us move on to the next question. Before that, I guess some of you are still trying to join the session, so let us include them. So let us move on to the next question. Fifth question is, which of the following statements are incorrect? Again, we are talking about the incorrect statement. First statement is, color measurement is done based on the principle of nephelometry. Option B, COD gives total oxygen needed for complete oxidation of organic matter. Option C, permanent hardness is caused by the bicarbonates of magnesium and calcium. Option D, conductivity is a measure of dissolved salts in water. So, which could be the correct answer?
See.
C.
C. Let us,
Op- op-
yeah,
Option B, madam.
option D. Okay, option C. Then what else?
Option B, madam. B.
Okay. So let us see the answer. Option C is the incorrect statement in this in these four statements, because option A is said that color measurement is done based on the principle of nephelometry. According to the principle of nephelometry, we measure the light which is getting scattered, and the light which is getting scattered is measured. So color measurement can be done based on that method. So it is a correct statement. Option B is, COD gives total oxygen needed for the complete oxidation of organic matter, which is a correct statement as we have discussed before. Here we are talking about COD and complete oxidation of organic matter. So that is a correct statement. Option C, it is said that permanent hardness is caused by the bicarbonates of magnesium and calcium, which is a wrong statement, because magnesium and calcium bicarbonate, yes, bicarbonate salts of magnesium and calcium, they cause temporary hardness, not permanent hardness. Permanent hardness is caused by the chloride and sulfate salts of magnesium and calcium. Then option D is conductivity is a measure of dissolved salts